Hello everyone, welcome back to physics class. In this lecture, we'll study about interconversion of energy and law of conservation of energy. About this thing we have talked earlier in previous lectures. Let's see it again in detail. What is interconversion of energy? This is energy converting from one form to other. Very simple example, common example is photosynthesis. In the process of photosynthesis, leaves of plants, they use solar energy, carbon dioxide, water to form their food, that is glucose. So in this process, there is conversion of solar energy to chemical energy. Chemical energy, that means in the form of glucose they store and they convert this sun energy to this in the presence of carbon dioxide and water. Similarly, if you see electricity production from water, that is from hydro energy to electrical energy. This is also a form of energy where this hydro energy gets converted to electrical energy. Any electronic appliances like let's say tube light or LED, what they do is they use electrical power and give us light energy. So that is example of this electrical energy to light energy. One more example, wind energy to electrical energy. By using wind turbines, windmills, we can convert wind energy to electrical energy. Like this type of conversion, you can find many other examples surrounding you. Okay, geothermal energy to electrical energy. Okay, in sun, nuclear energy to light energy or heat energy. So there are many other examples that you can see in this interconversion of energy. But one important thing that all these examples hold is conservation of energy. And that law of conservation of energy. Law means this is applicable to each and everything, for any type of energy. Okay, this law holds for everything. So this law says energy cannot be created nor be destroyed, or it can neither be created nor be destroyed. It can only be transformed from one form to another. That means in all these processes, solar energy is converting into chemical energy. Okay, so let's say if you have 100 joule of solar energy, then it is going to convert into 100 joule of chemical energy. If not, let's say it is going to convert into 80 joule of chemical energy and 20 joule of some other form of energy. But it is not going to happen that you have 100 joule energy you are giving and what you are getting is 120 joule. No, it is not possible. It cannot be created. So energy in this universe is constant. It is same. Only thing is it is transforming from one form to another. It is converting from one form to another. As the total energy of whole this universe is constant. Okay, so this is law of conservation of energy. To give one more example of this law of conservation of energy, these all conversion, they are going to hold this law. One more example is conversion of potential energy into kinetic energy. Let's say you have an object, a ball at a height of h. Let's say this height is your h. Now this ball, I have marked here different points A, B and C. And what we are going to see here is energy it is going to have at A, B and C, and how it is going to convert. So at point A, when object is at rest, it is going to possess potential energy. So at the point A, it is going to have whole energy, it is going to possess this potential energy, and here this point kinetic energy is 0. So at point A, you have maximum potential energy, which is mgh, and your kinetic energy is 0. Now when this object, it falls down, let's say this height at B is your half h, just halfway down. Now at B, as it starts falling down, its potential energy gets converted into kinetic energy. Okay, so whatever potential energy it has here, at halfway down, it becomes half of what it has at A point. So at B point, it has half mgh energy of what it has here. And the rest half potential energy is its kinetic energy. Okay, So at point B, potential energy is half mgh, kinetic energy is half mgh. You see, here addition of these two is mgh. Here also mgh. It is going to always be mgh, same. So whatever potential energy it is going to have at A point, though when it falls down it loses its potential energy, but its kinetic energy increases. And at point C, just above the ground, not at the ground, just above the ground, whole of its potential energy is going to convert into kinetic energy. So at point C, just above the ground, potential energy will be minimum, like 0, and kinetic energy will be maximum, that is equal to mgh, what it has here. So still here, the total, if you see sum of potential energy and kinetic energy, it is going to be constant. So you take not only these points, any point on this, let's say this E point or F point, at any point here, your potential energy plus kinetic energy is going to be constant. So let's say here you have 50 joule of potential energy. Okay, I will take any arbitrary point, let's say F here. Now if I say at point F, my potential energy is 10 joule, then kinetic energy will be 50 minus 10, that is 40 joule. Okay, but the total remains constant. It is going to hold this thing at each and every point, and once it is hitting the ground, this energy it will convert into heat energy or some other form of energy. Okay. So this law of conservation of energy, it holds for each and everything. There is conversion, there is no loss of energy in any process, there is no gain of energy in any process, it only transform from one type to another. Many times we are able to see that energy form, but many times like here when it hits the ground, the energy is, you say energy when it hits the ground is 0. No. It is converted into heat energy or some other form of energy. So, here we have done these two important topics, interconversion and conservation of energy. If you have any doubt, please contact me. Thank you.